Hi all, welcome to this, our final video in the lithosphere topic, and in this video we're going to be looking at coastal depositional processes and coastal depositional landforms. Now hopefully this video won't be a hugely long one as we don't have that many features that we're going to be discussing in this video, but let's get stuck in anyway. Now first, talking about processes. Now with our processes that we're going to look at, we've got swash and backwash and longshore drift. Now, longshore drift really is the core process that we discuss, and swash and backwash are a part of longshore drift. Now, when we talk about why we get beaches and why coastal deposition happens generally, we're looking at a couple of different kind of potential reasons. Now, one, if we've got areas like a bay, for instance, where it's very, very sheltered, and we see waves dropping in speed quite dramatically, we start to see beaches develop there. You know, as the waves become slower, they lose energy, and thus they can't continue to carry the sediment that they were carrying. If you've got an area where you happen to have a huge amount of cliffs collapsing and things like that, you can also get beaches developing there just by the sheer volume of material that's added into the system. The sea doesn't have the energy or the speed to get rid of it in time. And the last one is if we do have longshore drift, process we're going to talk about in a moment, it can put material into an area, it can provide material, which means beaches will build up. Now, swash and backwash. Now, swash and backwash are just the names we give for the action of waves either adding material onto a beach or removing it from a beach. So, swash is material that's moving onto a beach, and backwash is material that's coming back off of a beach. Now, depending on what type of beach area you have, if the area you've got is what we would call a constructive beach, or has constructive waves, those waves are going to have more energy adding material to the beach, so more energy when swash. So you're going to have a beach that gets bigger. If you've got what we would call destructive waves, they're going to have more energy when they are coming back down from the beach, so more energy in backwash, so they would actively remove material from a beach. Now, when we talk about longshore drift, we're looking at moving material along a beach. Now, this is, as is the case in a lot of places around the world, waves tend not to hit the shore at right angles. They tend not to be blown directly on, because wind direction tends not to bring them directly on. So with longshore drift, our breaking waves, or our swash, is moving at an angle. And as you can see here, it's coming at, this angle onto the beach. So material is going to be pushed that way up the beach. When it comes back down as backwash, it's driven purely by gravity. So it comes down at 90 degrees. Now what we see is that process repeats itself, where the swash pushes material up this way, backwash pushes it right down at 90 degrees, and it repeats and repeats and repeats. And the end result is longshore drift moves material along the beach in the direction of the prevailing wind. And as the direction of your prevailing wind changes, the direction that the material is dragged or pushed changes with it. And this is just another graphical demonstration of longshore drift. And if you were trying to draw it in the exam, so if you were explaining any of the depositional features that are going to follow, you would need to explain longshore drift first. This is the kind of diagram I would encourage you to use, where you can show, that dot, this is one piece of sediment. As swash comes in, it moves it to here and then to here. Then the backwash moves it from here straight down. Another bit of swash moves it this way. Backwash again moves it straight down, and so on. And you kind of do it 3 times just to make your point. And you're showing that this piece of sediment here has eventually wound up over here because it's being moved up at an angle, straight down, up at an angle, straight down, up at an angle, and straight down again. And that'll continue until something changes in the system, be that an obstruction, running out of coastline, things like that. Now, that's our process. So again, for any of the landforms that are about to follow, you would need to explain longshore drift first, and you would explain it fully. The features that we have are a spit or a sand spit, a bar, and a tombolo. Now, the good news with this is they follow on from one another. We explain longshore drift and how that can make a sand spit, and then you add on a line or two for either a bar or a tombolo, depending on what it is you're actually explaining. So first, and this is very slightly in the wrong order, which is slightly irritating, so I apologise for that. Looking at bars, we've got an area where we've got a bay. You can see we've got a little bay here, and we've got longshore drift is acting in this overall direction. Now that's going to move sediment across the mouth of the bay, and eventually the bar is going to block over the bay entirely, and that means this bay now becomes a lagoon. So if I'm explaining this, I'm going to explain what longshore drift is, how it operates, what swash and backwash are, and then I'm going to talk about how in the context of if I have a bay and a longshore drift that moves sediment and deposits sediment over the mouth of the bay, it's going to eventually block it off by forming a sandbar, and that leaves a lagoon behind the sandbar. If we're talking about a sand spit, and I apologise, I normally do this one first, I've just put these slides in very slightly the wrong order. I've got my bay again, but instead of it forming the whole way across, let's say that my bay is too wide, or the kind of tidal forces going in and out of my bay are too powerful for deposition to happen the whole way in. I'm still going to get a little bit of this deposition, and very commonly it's going to hook around, and that's my sand spit. This area of sand that has hit a corner in the coastline, and then it hooks its way around, building up. Behind that as well, you can also tend to get salt marshes, and we get them there because we don't have a lot of fresh seawater getting into this area to rejuvenate it. Now our last one, if I've got a tombolo, or how do I get a tombolo rather? So I've got my bay again, I've got longshore drift cutting across the bay. What if there's an island in the middle of the bay? If there's an island in the middle of the bay, longshore drift still working across, depositing material, kind of the same way as it would have done if it was a sandbar, except it makes its way all the way over to the island, and this is now a tombolo. So I'll leave this visual up for a moment. So tombolos and bars are both sand spits, but they're sand spits in particular contexts. A bar is a sand spit that is entirely crossed over the front of a bay, and a tombolo is a sand spit that has crossed a bay and it's met up with an island that is in that bay. Now, a bit that is worth adding into the end of your sand spits is most of the time these are temporary features. As you know, the work of tide, etc., continues, they can dissipate and they can vanish. However, sometimes if they're particularly large and if they've got a lot of material being deposited and they can stay up above sea level for protracted periods of time, you can have vegetation that will colonise on top of it. And once that begins to happen, you can get a bit of permanence to these features, and they can be there for quite a long time. Now I'm going to wrap this one up here, guys. It's a sub 10-minute video for once, which is not something that's particularly normal for these videos. Remember again, like I'm saying, your big process with all of these features is longshore drift. You must explain how longshore drift works first if you want to be able to explain these in any form of real depth. So we're going to wrap these things up here now, guys. As I say, this video I'm expecting you to have watched after the coastal erosional features. And remember, in the exam, it's quite common for you to be asked for a bit of both of these, so you need to be comfortable with all of the features that we've discussed. That's going to be the end of the lithosphere videos, so until next time, I'll see you guys later.